Now in this video, we'll continue with the configurations what we did in the previous task here. Like in the previous task, we have seen, we have already built one point-to-point connection, GRE point-to-point connection between router 1 to router 2. And then we have implemented some EHRP on it, and 192.168 1 network and 2 network, they're able to communicate over the tunnel interface. Now we're going to continue the same configurations, and we are going to build a logical tunnel from router 1 to router 3 as well. And then we are going to build a the GRE tunnel between router 1 to router 4. So which means we're building one more tunnel from here to here, and then one more tunnel. So GRE is a point-to-point. We cannot have multiple destinations in general in the basic GRE implementations. So point-to-point tunnels. And then after that, once we are building that, then we are going to run some EHRP protocol, and we'll ensure that all the LAN users like router 2 should be able to communicate with router 1 LAN. Also, it should be able to communicate with router 4 as well. So all my branch offices should be able to communicate. So let's go to the router 1. On the router 1, we already have one tunnel which is between router 1 and router 2, and we are going to build two more tunnels, and those two more tunnels will be between router 1 to router 3 and router 1 to router 4. So let's create one tunnel with 1.3 name. This is between 1 and 3, and the IP address I'll be using 10.0.13.1, and I'm using /24 subnet mask, which makes these two between different networks. And the tunnel source I'm using 0.0, and the tunnel destination will be the router 3 public IP address. In my scenario, it is 35.003. So 35.003, that's it. Let me create one more tunnel, that is 1 to 4. And the IP address for the tunnel 1 to 4 will be 10.0.14.1, and then 255.255.255.0. And the tunnel source will be my S0 by 0, and the tunnel destination will be my 45.004, the public IP address of the router 4. Done. Now once we configured this, now we can see this is what we have done. On the router 1, we are creating three tunnels. One is from router 1 to 2, 1 to 3, and 1 to 4. Now let's go to router 3, because already on the router 2 we have configured. So we'll go to router 3, we'll create one tunnel, that is 1.3. And the IP address, it has to be on the same network, that is 10.0.13.3 I'm using. And then tunnel source will be my own interface, and the tunnel destination will be the remote IP address. So in my scenario, it is 15.001 is the public IP on the router 4. Now I'm going to copy the same commands on the router 4 as well. On the router 4, I'm going to create one tunnel 1.4, and the tunnel source and destination almost the same because there's no difference here. And then the IP address will be different network because they are different point-to-point connections, so they should be on a different network. So 10.0.14.4, and then that's it. So our tunnel is up. Now we are done with the configurations on the router 1, router 2. Let's verify the configurations. Show run interface tunnel 1.4. Now we got the configurations correct. So now once we are done with the configurations, now I should expect the router 1 should be able to ping to the router 3 tunnel, that is 10.0.13.3, the IP address which I used on the router 3, and 14.4, the IP address which I used on the router 4. So which confirms that your reachability between router 1 to router 3 is okay, and router 1 to router 4 is also okay. Now we got the tunnel up. Now once the tunnels are up between router 1 to 2, 1 to 3, and 1 to 4, now we want to ensure that the LAN users should be able to communicate with each other. So we are going to run some routing protocol for that. So I'm already running EHRP on the router 1, and on the router 1, already I'm advertising, if you verify show IP protocols, already we are advertising the 10 network and 1 network. So I don't need to advertise 10 network again, because automatically when I say 10 means these three also will come under that, because they're using 10.0.13, 10.0.14. So I don't need to do any advertisements on the router 1. If you want to be specific, we can use wildcard mask, but I'm not using it here. So let's go to router 3 and then advertise 10 dot network, and then advertise 192.168 3 dot network. That is in my LAN. You can see the neighborship is up. Let me do the same configuration on the router 4. The only difference is I need to change the LAN interface IP address to 4 dot network. Now I can see the neighborship is established between router 3 and router 4. Let's go on the router 1 to verify that. On the router 1 I should see 3 neighbors. Now I'm able to see 3 neighbors, that is, one is router 2, router 3, router 4 on tunnel 2, tunnel 1 2, tunnel 1 3 and tunnel 1 4. So the neighborship is up. Let's verify the routing table. I should see the routes coming on the routing table. You can see 192.168 2 dot network, 3 dot network and 4 dot network. They all are coming from different routers on different tunnel interfaces. Let's go to router 2 as well. Show IP route EAGRP. Now on the router 2, I can see the routes here. You can see the routes are coming. I'm able to see 192.168 1 dot network and 3 dot network. They all are coming from router 1, that is 10.0.12.1. Now the reason is, the router 3 do not have a direct tunnel between these two. We don't have a tunnel. So anything from the router 3 will go to router 1 and the router 1 will send back on the same thing. Here you can see it's going via router 1. So the router 1 is a centralized hub where you have all point-to-point connections configured. Now if you try to trace 192.168 3.3 or 4.4, I can see the traffic goes via router 1. Now if you don't want to go via router 1, in that case we need to have one more tunnel between router 2 to router 3, and if you want direct communication from router 2 to router 4, we need to have one more tunnel. So like that, the more number of sites you want to add, the more number of tunnels we need to create. So that's one of the major drawback with the GRE, normal GRE implementations, where they are more commonly referred as a point-to-point implementations. And if you have more number of sites and you want to have more number of point-to-point links, we need to add more and more number of point-to-point tunnel configurations, and then we need to implement with some routing protocols.